Neurodesk is an environment to analyze neuroimaging data. And what it provides is all the neuroimaging software that we're used to. So FreeSurfer, FSL, AFNI. And our idea was, let's make this really accessible and easy to use. So you don't have to install anything. It just works out of the box and it works correctly. And it's reproducible. I think John Baptiste Pauline always says this, the bus factor, right? If I get run over a bus, what happens with the project? And I'm confident to say today
that before.
Yeah, exactly. And I think it's true, right? I think projects like this shouldn't be run out of one lab.
Welcome, everybody, to Andy's BrainCast. My name is Andy Jan. I'm a research scientist at the Functional MRI Laboratory in the Department of Radiology at the University of Michigan. And today I'm joined by Dr. Steffen Bollmann, who is a research fellow at the Center for Advanced Imaging at the University of Queensland in Brisbane, Australia. In addition to other fields of research, Steffen is investigating using high signal levels of ultra-high field 7 Tesla MRI to quantify disease processes at a very fine-grained spatial level of detail. In addition, there was a paper that he was a senior author on, published this year, 2024. Lead author, I believe, was Angela Renton, published in Nature Methods about a new software package called Neurodesk, which I'm hoping we'll be able to discuss in some detail today. So just some background for the viewers and listeners about how we first got in touch. About a year ago, I went to a very small conference hosted by Chris Riordan, the developer of MRI-CrowGL. He's probably most well known for that, at the University of South Carolina. And one of Steffen's colleagues, Ashley Stewart, gave a demonstration of Neurodesk. The point of the conference was to illustrate some different web-based applications to make it more accessible, regardless of what kind of operating system or hardware that you've had. And I was really impressed, and I saw the potential immediately. And I'll say right now, I've had a very good experience with it. I've used it for workshops with numbers as small as half a dozen to 80 plus. Works great. And I'm hoping we can talk more about it because I think it's a really important development in the field of neuroimaging. So welcome, Steffen. Thanks for being here.
Thank you for the invitation. That's great. Thank you.
Of course. Well, to get started, I know we had a few things we were discussing beforehand, and I've already previewed it a little bit. I've hyped it up, but in your own words, what is Neurodesk and how did you come up with this idea?
Yeah, so Neurodesk is an environment to analyze neuroimaging data. And what it provides is all the neuroimaging software that we're used to. So FreeSurfer, FSL, AFNI. And our idea was, let's make this really accessible and easy to use. So you don't have to install anything. It just works out of the box and it works correctly. And it's reproducible. That was the idea. And it was really born at the hackathon, at the OHBM 2020. So during COVID, when we were all sitting at home, we had a hackathon project that was proposed by Oren Sevier from University of Swinburne in Australia. So he had this project and he said he wants a virtual neuro machine. And things like this existed before. So NITRC had a virtual machine and FSL had a virtual machine and FreeSurfer had a virtual machine. So people had distributed their software using virtual machines. So the idea initially was, can we just install all the software into a virtual machine and distribute it? The challenge that we quickly ran into and saw is then this machine would get really big and would consume a lot of memory and disk, and it wouldn't be easy for people to use. So at the same time, we had already done lots of containerization of applications. So I had done in the past years, I had to use multiple HPCs. So I had some experience using Singularity and Aptainer containers. So that time it was Singularity. Later they forked off and the open version is now Aptainer. So we had some experience that containers could really help us a lot there. And there was also a cool project called Neurodocker. Neurodocker is a project in the ReproNim project portfolio. And they had created a list of recipes where they described in a nice description format how to install, for example, AFNI or FSL into a container. And that's why they call it Neurodocker. It was based on Docker. Could also write Singularity containers. And we said, let's use that. Let's start building lots of different containers. And then let's see if we can run them in another container. So containers and containers. And that's really how the project was born. So we very quickly, in 2 days, we had a prototype up and running of a Docker container that provides us a virtual desktop. And then inside this Docker container, we had Singularity containers running that would then provide these individual pieces of software. And what we could do with this is we had now different versions of the same software. We could install them next to each other. So for example, FreeSurfer, we could install in different versions. And in a single virtual machine, this wouldn't be possible because you have dependencies and these dependencies conflict with each other. But because we have every software version in its own container, we can then have them installed in parallel. And with this, we can also run on high-performance computing clusters, and we can also go in the cloud. And then we had a prototype. We said, this is really useful. People started testing it and piloting it. And then we sought funding. So we went to the Australia Research Data Commons, the ARDC, and they had a platform project call. So we said, this is a really cool platform that people could use to do reproducible neuroimaging. And we pitched it with the idea of making EEG and MEG analyses easier, and also working with open data like bits and making bits conversion easier. So we had a whole package around this. And we were 3 universities in this project. So Swinburne University, UQ, where I'm at, and University of Sydney, where our colleagues were. And yeah, we then had 3 years to build this platform out. And that's pretty much what Neurodesk is today.
It's really impressive, especially it seemed like some of the architecture was already available and you just saw the opportunity to integrate it in a manner that it was quick, it was easy. It doesn't mean that people need a Linux distribution, anything like that. It really should work across Windows, Mac, anything.
Yes, that was always our idea. We wanted to have something that works what people have available already. So Windows, Mac, Linux, HPCs, cloud environments. And one big idea was also we didn't want to reinvent the wheel. So we wanted to use things that are available and that are just working. So we didn't want to invent like micro virtual machines or something like this. So we're playing with new technologies these days and see where we can push this. But at the start, it was really what's available today and what can we piece together to make this work. Yeah.
Well, it's impressive that it seems to work so smoothly. I mean, I'm speaking from my own experience, but really any machine I come across and anybody I assign Neurodesk to, they can run it without any problems at all. And just for the people who are listening, as Steffen mentioned, there are many different, I guess, instantiations in which it comes in. Probably the most popular one that you can use right out of the box is on the neurodesk.org website, where you can simply press play. It'll set up an environment. And although there are certain restrictions, you can't upload hundreds of gigabytes of data, you can get a sense of what it can do.
Yeah, exactly. So Neurodesk Play is really where we said, let's get people started without having to install anything. So what we've done there is we use cloud resources. In the beginning, we were sponsored by Oracle Cloud. Then this sponsoring ended last year. So we then found, luckily, university cloud providers that provide us with resources. So in the US, this is Jetstream Cloud. And Jetstream Cloud runs out of the Indiana University, and it's managed through the Access program. So pretty much every researcher in the US has access to these resources and can even request their own resources to run Neurodesk on their own cloud resources. And in Europe, we have the EGI Federation, which provides us with cloud resources. In Australia, it's the ARDC, which also funded us. They have also a cloud called Nectar Research Cloud. So that's how we provide these Play services. And yes, they are the idea is that we can provide it ideally to as many people as possible. And well, fortunately, we had pretty much exponential growth in the last month. So that meant we really had to struggle to provide the resources for people. So what we sometimes had problems with is that we're just not enough resources. And that's always the problem, right? Whatever room you have, you will fill it with stuff. And that's the same with compute resources. In the beginning, we even had problems with crypto miners because they took our free resources and mined Bitcoin, which of course we quickly had to do something against. So we hired a research assistant with a cybersecurity background, and they really helped us to get rid of these crypto miners. And we really made sure that the resources we have available are for researchers to use. And we have to limit the resources quite a bit to be able to provide it for all people. But yeah, if anyone runs into resource limitations, let us know. We can then go back to the Jetstream Cloud or EGI Cloud and say, look, we have a lot of users on this and they love it. Can we get more resources? It's a chicken egg problem, right? We can't ask for more resources without using them, but then when we use them, we can't quickly get more resources. So it's a slow process where we need to show the use case, and then we can also ramp these things up more. Then if you need more resources right now, what you can do is you can run Neurodesk locally on your computer. So the easiest thing there is Docker. Docker works quite well on macOS, Linux, Windows. It has some issues. So for example, if you don't have administrator rights on Windows, you can't install Docker. Docker also comes with some license restrictions. So for example, if you are in a commercial entity, you're potentially not allowed to use Docker in the free version. So that's why we supported Podman. So Podman is a free open source alternative to Docker. And we just added this support in a couple months ago. And Podman pretty much works identically to Docker. It has some performance limitations on macOS, but they're working on this as well. So when you download our app is an Electron app that makes it really easy to start up this container. So you actually don't interact with Docker a lot. You just click, I want to run this locally, and then we figure out what operating system you're on. We issue the right commands. We mount the correct storage location. So we, for example, give you a directory that's shared between your computer, and we then give you that inside the virtual machine. And yeah, with this, we have some ways of making this easy. And then, of course, if you run it locally, you still run into resource constraints eventually. Some users we have, they run it on really big workstations, like a 192 gig RAM workstation with 128 cores and lots of disk space. And then they run all the analysis on this, and this works really well, especially if it's a Linux workstation. On Windows, we still have some issues with sharing files between Windows and Linux. People might run into this when they try to convert 1 million DICOM files they have stored on Windows. Then this whole file sharing will start to get really slow. On Linux and macOS, this is a bit easier. So what a lot of people do is as well, they convince their university to install it on their high-performance computing cluster. And a lot of universities have done this. So University of Queensland, of course, lots of universities in the US, Ghent University in Europe was one of the first one who installed it on their HPC and provided to all users. And I think this is really, ultimately, this is probably the best way of doing it, because the university has good storage infrastructure, so your data is secure. They understand the compute requirements. They can give you enough compute requirements that you need for analyses, and they just look after the application. And we also have universities who don't have local support like this. They run it in the cloud. So AWS, Google Cloud, they are all really great for this as well. We can run on anything that supports Kubernetes. In the end, we need a virtual machine at least with some storage and RAM, and we can run on it. So that's also something, a big advantage of using containers and very mature technologies. It means we can pretty much run anywhere. So these are probably the most common ways of accessing it.
That's great. And getting back to, the resources that are available, let's talk about somebody who isn't making huge demands on Neurodesk. They want to download it locally. They have 1632 gigabytes of memory on their workstation. You mentioned that for larger projects, let's say for workshops, for example, you're talking to people like the Jetstream cluster at Indiana. So what I'm trying to say is, when you helped me set up a workshop for about 80 people, we had to make sure it worked for everybody, even though they're working with relatively modest computers on their own. A lot of that you did take care of. And just under the hood, what do people need to be aware of as far as resources? You say usage is increasing exponentially. Is there ever a problem with a couple of thousand people get onto Neurodesk at the same time? Is that going to crash anything? Do people need to worry about that? Because a lot of people using it don't have the same expertise in the infrastructure that you do.
Yeah, it's a good question. So we, in the last months, and was really, pretty much our last year, was really making sure that this doesn't happen. So we moved over from the Oracle Cloud to AWS. So AWS supports us a lot to manage a system that's worldwide distributed. So there are a lot of components of the system underneath that make sure that the software gets streamed to your computer. So because what we do is, and I didn't mention this earlier, when we initially experimented with this Docker container with lots of little containers inside, we realized that very quickly we end up with a massive storage consumption on people's computer.
Mm-hmm.
So that was like 600 gigabyte. And people don't have that big disks, right? If you buy a MacBook Air today, it's 256 gigabyte disk. So that wouldn't be enough to store all of that. So what we quickly did is we said, let's stream the software. And for this, we use a very mature software again, which was developed at CERN. So CERN distributes software worldwide through a system called CERN Virtual Machine File System, or CVMFS. And CVMFS is really built for scale. So that's the cool thing. What you do is you have one server that we run and where we ingest the original containers and software. And then we have mirror servers worldwide that distribute this software to all the people in the world. And the cool thing is that we can very easily just add more servers. And the cool thing is we can also use a technology called CDN. CDN is a content delivery network. And what we do here is we use existing networks. So the community around CERN, so Fermilab and all of these labs around the world who collaborate with that, run already such services. And they have a professional setup that supports thousands of users. So what we asked them to do is we said, can you host our repository as well and distribute it through your infrastructure? And that's what they do. So we have a really cool distributed infrastructure that's managed by scientists worldwide. So also the cool thing, it's not dependent on our funding. And then in addition to that, we have AWS resources with their CDN version where we have additional servers. And we really looked in the last months, where are our users and how can we get servers as close as possible to the users so they're seeing a low latency and this works really well. So this is really getting the software to users. And this is independent of where you run Neurodesk. If you run this on your computer, if you run it on the cloud or on HPC. So we have to make sure that this works. And we really spend a lot of energy on making sure that this is efficient and cost efficient and reliable and secure as well, because you don't want like a virus in there.
Of course, yeah.
Yes. And then, running the resources for computing, this really depends on what you want to do. And the most current limitation I see is actually storage, because we consume a lot of storage. When people come and say they want to analyze the UK Biobank data, that's very quickly hundreds of terabyte of storage that you need, right? If you just need structural scans and a bit of diffusion, that's a couple hundred terabyte very quickly. And that's usually the fundamental limitation that people run into. How do you actually store this data, and how do you get this data storage connected to Neurodesk? So that's where you often need IT infrastructure, people who understand how to do this best.
Well, are there plans to expand the scope of people who are funding this? Because it sounds like this is a really useful global resource. And obviously, we don't want, at some point, Neurodesk to stop working, because if people already have some invested interest in having it currently running, we want to make sure it's a going concern. So what do you see the prospects of for the next 5-10 years as far as viability, usability, any restrictions on how people can use it? What are your thoughts?
Yeah. Yes, to get the funding from ARDC, to get this to develop it, we had to come up with a sustainability plan already before we start. So they said, we give you funding for 3 years, and after that, you have to be sustainable. So we came up with lots of different ways and ideas how to make this sustainable. So the first one really is we still need funds and grants to build new functionality. So one thing that we just got awarded is a Mark and Chan Zuckerberg CZI Essential Open Source Software grant, which is provided to us through the Wellcome Trust. And this is a grant over the next 2 years where we can build new features in Neurodesk. And we can also increase community buy-in and support of the community. So the idea is, can we make it so easy for people to contribute to the project that the community can maintain it? That's one way. And can we make this infrastructure so resilient that it doesn't need funding to keep it going? So this is, for example, why we rely on the Open Science Grid, which hosts a lot of these things. We rely on GitHub, all open source technologies. So we really try to lower our financial footprint as much as possible so that we don't need continuous funding to be alive. And
I see.
Yeah, even if all funding goes away, everything we've built will be there and will be working. There will be no new features coming, of course. But of course, we still want to keep going, right? So that's why we keep applying for grants. And the other thing is we have a model where we said, because like workshops like you, right? They often approach us and say, can we run Neurodesk for a big workshop? And what we've done there is we have a non-for-profit organization here in Queensland, which is called the Queensland Cyber Infrastructure Foundation. And what they do is they can take open source projects and run them in a professional manner for example, workshops, and then also charge, for example, workshops for this. And the idea is that we can, with this, have a professionally supported environment that people can purchase for a workshop, and then some of these profits then flow back to the open source project to support it growing and being maintained in the future. The other thing is cloud providers. So I mentioned already we had been funded and supported by Oracle Cloud in the beginning. They gave us a lot of cloud credits. Then we had a quick section where we were on Google Cloud. They supported us. And currently our main partner is AWS. And AWS sees a lot of value in this as well, getting customers into the cloud and also ideally expanding it beyond the scope of neuroimaging. And they support us a lot with cloud credits so that we can really experiment with new ideas and we don't have to be always afraid of the costs that come with that. So that's really fantastic. And they're also, of course, not just giving us credits, they're also giving us expertise. So for example, we went through this well-architectured framework program where we looked at our infrastructure. How can we make it resilient, cost efficient, robust, secure, and all of these things. And just the pure amount of resources we got from AWS in terms of, okay, well, this is not good. You need to change that. That is really helpful to get us in a space where we can hopefully grow in the next years and be also sustainable.
That's an interesting trend, collaborating with some of these larger organizations, obviously have a lot of infrastructure and resources to support this. And yeah, I assume that that's a trend that's going to continue because we simply need it, really. Especially, you're talking about UK Biobank, and for those who may not be familiar, this is roughly 40,000 subjects, last I heard, people who are registered with the National Health Service in Great Britain. And they've collected all kinds of data, neuroimaging, behavioral, phenotype stuff. And it's an incredibly large data set, kind of seen as, well, I believe it is the biggest neuroimaging database that there is currently. And if people want to keep, investigating it, they're going to need access to really heavy-hitting resources like that.
Yeah. Yes, and the UK Biobank also has their processing portal, the UK RAP, and they're trying to get people only using that one to interact with this data because, people have been overwhelmed with downloading all of this data, so they want to help there a bit, but the problem is also still cost. So it's not free to access the open biobank data, or the biobank data, it's not open. So you have to actually pay a lot of money to access it. And then if you want to run analyses on this RAP portal, you also have to pay. So it's actually, I think, really good to have open source solutions like Neurodesk who can support people in processing this data. And I think we have to see as a community how we can handle that. One thing, for example, we're also looking into, can we integrate better, for example, with OpenNeuro? So OpenNeuro, for example, has this button of view a data set, and then we could maybe get a Neurodesk link in there as well. We're still working on our core infrastructure right now, but that's, I think, something I want to do very soon so that people can just go on OpenNeuro and say, analyze this data set in Neurodesk, and then it appears magically there and it's just working. So that's definitely something I want to do, or we want to do very soon. So let's see if this is coming.
Let's stay with that thread, actually, because I see that more and more. Franco Pastilli out at UT Austin right now has a similar idea in which people will upload, I think it's datalife.io.
Okay.
BrainLife, in which you're able to upload your data essentially to the cloud. You can click on a variety of different processing pipelines and then download it if you wish. And I believe that's obviously an interesting and useful trend. Do you see any downsides to having this somewhat, they call it, black box approach, somewhat pejoratively, but there are a lot of useful aspects to that in which you can send it out, tell it what you want it to do, and then receive back the finished product. Is it all or nothing? Is there any kind of intermediate step between that where you can have more control over what's happening at certain steps? A lot of people like to customize. Some people don't agree with, say, everything that goes on in BrainLife or fMRI prep. How would you respond to that?
Yeah, I see it as a big continuum. So also that's something I didn't mention quite in the beginning, but Franco Pastilli and the BrainLife team were involved in the Neurodesk platform grant in the beginning, right? Because
Oh,
we said,
okay.
we are not reinventing the wheel. We're not doing something that other people have done already. We want to augment things and interoperate. So that was one big theme in the grant. Can we interoperate with these platforms? And Franco Pastilli is on the Neurodesk paper, and we are also on the BrainLife paper. So we're very well aware. And currently, actually, my postdoc, Ashley Stewart, he's currently in Franco Pastilli's team in Austin, and is actually working on integrations between platforms and harnessing the best of these different worlds. So to me, it's really a continuum. So I think you need, and that's why we built Neurodesk, because it didn't exist yet. I think just to highlight the strengths of both platforms, BrainLab is fantastic if you want to run fMRI prep, a standardized bits pipeline. So if your data is in bits and you are allowed to upload this data to, for example, BrainLife, and you want to run a standardized pipeline that you don't want to fiddle with, it's perfect. It's wonderful for this. And then you can analyze it. You can benchmark the data. You can also get more control if you want to. But I would say the primary thing is standardized pipelines, bits data. Neurodesk really comes from the other end. So Neurodesk says, okay, what if my data is not yet in the bits format, right? How do I get my data actually into bits? And how do I help people to get it there? And also, let's say I'm working on something new. There is no standard pipeline yet. I want to do something that doesn't exist yet. And I think Neurodesk is fantastic. You can combine different tools, figure out something new, then package it as a container, and then potentially even run it later on BrainLife. So that's definitely something we are thinking about. How can we get these platforms now closer and more interoperating? And we've already done a lot in this space. So for example, our QSM pipeline, QSMXT, we build it on Neurodesk, and it's perfectly integrated there. But now Ashley Stewart took this pipeline and made it work on BrainLife and on other services like Flywheel and QMenta. And so I really see it as a continuum. I think it really depends on what your use case is. If you have clinical data that you can't upload anywhere, you want to keep locally, Neurodesk is the way to go. Mm-hmm. If you process large open data sets, BrainLife is perfect. And I think there's a big intersection in between where you could use either or both platforms. Doesn't matter. And then I think there are really strengths where only one platform can do it. And I think, it's good to have that choice for people. There are also similar platforms to BrainLife out there. So it's not the only one that does it. But I think it's good to have that choice. And I think especially when you're learning about neuroimaging, and I think Neurodesk is fantastic because you can go under the hood. You can see absolutely everything that's happening. And it's just exactly like the tools describe it. And I think that is a really big plus for why we build it that way.
I agree completely. And I'm trying to get people to switch over to it here. Not like they have to use it, but if there's somebody who's a newcomer to neuroimaging, you may as well put them in this environment where they know they're not going to have any problems installing anything. They know there's not going to be any problems with versions or path conflicts, and they can still use whatever their lab wants them to use. They're just in a slightly different environment, and you download it once it's done. Yeah, I really don't see any reason not to use it. I just want to backtrack a little bit to what you mentioned about clinical data, because I do get this question quite a bit, and I just want to put it on the record here, is that if there's data which you have some privacy issues, concerns about that, you probably don't want to use the cloud-based Neurodesk application. But if you download the container to your local machine, there's no risk of data breaches, for example.
Correct. That's why we build Neurodesk. And we do put a lot of emphasis on security there as well. So there's still potential risks involved if you execute a container that could potentially steal your data or something and then upload it. But we're trying our best to make sure that this is not happening in terms of scanning the containers for vulnerabilities and things like this. So yes, so that's really why that was the gap we identified. We said there is nothing really because we had XNet and Flywheel and BrainLife and QMenta. These platforms existed before Neurodesk. So people ask, okay, what can Neurodesk do that we can't do already with these platforms? And I think this is the big thing. You can take Neurodesk and install it on your computer and have your clinical data there, process the data. It never leaves your computer. It should never leave your computer. And what we're currently working on as well, this is something hopefully coming now in the next 2 years, and we have a first prototype ready. It's called Neurodesk Portable, And it's the brainchild of a postdoc in my team, Josh. And Josh is an expert in micro virtual machines. So what he can basically do is he can spin up a small virtual machine that can run anywhere without privileges, without internet connectivity. So this is really cool. So this means we can run Neurodesk in an air-gapped environment. It doesn't even need internet connectivity. So the idea is you take it on a USB drive, you download every container you want. So you click, oh, I want FSL, I want AFNI. It will download these things, put it on a USB drive. You can take that USB drive and take it to a computer that's not even connected to the internet, and you can do your analysis. And this is something that people have asked us, and where they have these issues that they actually are in an air-gapped environment, like especially if you run MRI scanners, right? We know most of our MRI scanners are not connected to the internet because of security, right? You don't want anything that's so vulnerable to be connected to the web. So our scanners are air-gapped, for example. And this is, so this is an exciting project. I'm looking forward to get into people's hand, and but just testing that with the first few users who have these problems. I think that's very exciting. So it will be, really, it will allow people to analyze very sensitive data. And we're also involved in a project where we run Neurodesk inside a secure enclave. So this is also an environment where every data that goes into this environment and out of this environment is logged and authenticated. So you actually can't take data out. This is for a project where people want to analyze. So this is now going out of the neuroimaging domain, dermatology data. So it's a full body scan of a person with camera. So they're actually naked. And what they do is they scan for skin cancer. And this is a big problem in Australia, obviously, because of our high exposure to sun here. So we have the highest rates of skin cancer, and we have imaging systems, whole body imaging systems, where we want to automatically detect these skin cancers and monitor them. So for this, we need a secure environment because, if you don't want these images anywhere else than a secure environment. And this is also why we're building these tools to really analyze very, very sensitive data.
Wow. Yeah, that obviously potential for any kind of imaging, really any kind of science that's done through software. I mean, this approach, I think, is going to be predominant. Definitely. So moving from there to reproducibility, Neurodesk is definitely a way that people can really be on the same page with the software they're using, with what they can do. I've seen you demonstrate a way to, use Jupyter notebooks in collaboration with GitHub to basically document everything that you're doing through a certain analysis. And I just want your thoughts on that, about what the prospects are, especially with the field that has been talking so much about open science and reproducibility lately. How does Neurodesk facilitate that?
Yes, that also goes back to why we build it. Because I personally was also very frustrated when I got scripts from someone else, right? You get a shell script and say, oh, this worked on my computer, and you run it and it just doesn't work. And even they tell you need to install FSL in this version, you need to install AFNI on that version. And you're running into Python problems, you're running into R package problems, especially with AFNI. AFNI needs very particular versions of Python and R, and everything has to be just installed in the right way. And you have to be lucky sometimes to get an environment that's similar to someone else's computer. And that's really why we built it. So we wanted a way where we can say, this is what I ran on my computer, and it should run on your computer. And this was always the fundamental thing on Neurodesk. This should be possible. So you should have a Bash script or a Jupyter notebook or anything else, really. And you take it on one Neurodesk, it runs there, and you put it on another Neurodesk, and it will run there identically. So that was also always the goal, and we achieved that. And I think this was never possible before. You could never control an environment that tightly. We use standard software again to do that. So we use the LMOD. LMOD is an environment system that can load software into the environment path. With this, we can control the paths very well. And that means if you specify, I want FSL 603, you will get that software. And we have a lot of checks to make sure this is the case. And this really gives us this reproducibility across systems. There's one caveat there, and we show this in the paper as well. We cannot control hardware. And this came a little bit unexpected, but also a little bit expected to us. If you run something on an Intel processor versus an AMD processor, you will still get slightly different results depending on the pipeline. So this is the interesting thing. We show this in the paper that like in one pipeline, you're not getting any differences in Neurodesk, not even depending on the processor. In another pipeline, like the fast segmentation pipeline, you do get some differences. And we showed that this is not based on software. So in software, we actually take the same execution paths in the binary. So we trace the execution calls. So we know we're doing exactly the same thing. But the processor that's running in the system is doing things slightly differently. Like the floating point is just slightly differently implemented, which gives us tiny effects still that are different between different computers. So I would say if you want absolute reproducibility, we still need to use exactly the same computer. But I would say we're now in a range where it shouldn't matter anymore. I think the main thing that we wanted is it runs and it gives you pretty much the same results, but not down to the last digit in a floating point precision. So that's really the caveat I have to say there. And one vision I have, and I hope this comes into life, there's some great projects out there. For example, there is a project, I think, running out of Montreal, and they're called NeuroLibre. And NeuroLibre has this idea of a computational paper or a notebook paper where you write everything this paper is about in a Jupyter notebook. All the code is in this notebook, all the data is there, and you can re-execute that whole paper. And they have a preprint server for these computational notebooks. And also eLife started experimenting with some of these executable papers. And I think this could be really fascinating, right? So I think we're hopefully transitioning from a model where we have a PDF that's pretty useless, right, for computational reproducibility. Because when I review papers, sometimes people don't even mention the R version that they used or the packages they used. So it's basically impossible to reproduce. And I think if people start, for example, providing their analyses in a Jupyter notebook, in a GitHub repository, this is a lot better. And if they use Neurodesk as well, it becomes really easy to take this analysis and base your analysis that you want to do on this, or check it, change variables, see how sensitive these results are to parameter changes. Because we know that a lot of these, like the analytical flexibility papers show quite nicely that if you change certain parameters in the pre-processing, you can get different results. But it also shows that overall, a lot of the most robust results are there and they're good, right? You can't destroy certain things that are just very robust, even no matter what analysis choice you do. And then certain small things can change. And I think this is also where we come into this multiverse analysis where we can maybe even, on purpose, do the analysis slightly differently and do a sweep across different packages and then do a meta-analysis on this and see what is robust actually. And I think there's some cool work coming out of a couple labs there in this space. So we're also proposing an OHBM workshop on this potentially with John Baptiste Bollmann and a couple other people, Tom Nichols, who all work in the space, and see how can we use Neurodesk to help with these multiverse analyses, and then how can we get good statistics on this. I think this is still not quite understood. How can we do inference on this then? But people are working on this, and very clever people are working on this. So I hope we can help with this. That would be great.
Yeah, absolutely. I should mention that next year's OHBM, which will be in Brisbane, which I think you're very happy about, not having to travel too much for these other conferences.
Yeah, that's great people in our city. So yes, I hope many people can come. And also mentioning OHBM, we just got funding from our university in Queensland. The Global Outreach Initiative program said, okay, Neurodesk is something that people use worldwide. We want to support it. We will run a workshop with Neurodesk, and we got funding from the university to offer this workshop for free. So we're still in discussion with the OHBM hackathon. So we want to do it at the hackathon event so people don't have to commit to too many events. So idea is we will be there on a Saturday morning, run a really nice Neurodesk workshop, and then also have hackathon projects around Neurodesk. And it will be free. And we hope lots of people come to this and help us make the software even better.
That's great. Yeah. Just if you could indulge me, just give some more details about what you think will be done during that workshop, which is going to be the Saturday before OHBM proper. They have these kind of satellite conferences.
So I think the hackathon currently will run from Saturday to Monday. I think it will be a 3-day event. We will have the hackathon, the brain.
Yeah, in June. I forget the exact dates, but whenever.
Yes. End
OHBM
of
is,
June, exactly. I also don't
Yeah.
have the exact date. I think 26 or something like this.
Okay.
So yes, it will be announced hopefully very soon. As I said, it's still in discussion how we do it, but that's at least my plan right now. That we run it like this, and yeah, then what can people work on? So I think our biggest bottleneck right now is adding new software to it. So it is actually, we spend a lot of energy on making this easy, but unfortunately it's still hard. So I can quickly dive into this a little bit. So one thing is we use Neurodocker. So Neurodocker is already an abstraction on top of Docker. So it makes installing software a lot easier. But in the end, what you still have to do is you have to figure out what Python version do I have to use, what R version do I have to use, how can I compile a certain R package in a certain environment, and you still need to understand how this is happening when you build a new container. So it's unfortunately not that easy. So we have, however, because we're now doing this since a couple of years, we learned a couple of good ways of doing this. So what we want to do is we want to build, and this is also coming from the CZI funding, we want to build an interactive container builder where you can quickly go in and you can try out things, and it's really quick. So we cache a lot of things, and you can try this R version and that R version and that Python version, and quickly build these containers, and then make it really easy to test these containers and submit them to us. So this is something we hopefully have ready for the OHBM 2025 in Brisbane, and people can work on this. So this is probably the easiest way to get started. The other big thing that we're working on, and this is also coming from this CZI Wellcome Trust funding, is we want to build an interactive neuroimaging teaching learning material. And this is really based on your work, Andy, right? Your Andy's Brain Book. It's such a fantastic resource where people say, oh yeah, cool. I learned all my neuroimaging from that. And we looked at this and said, well, maybe we could even add interactive examples on top of that, where it's not just describing what you can do, but you can just take a notebook that runs on Neurodesk and does that analysis. And then you just plug in your data and see what it does on your data.
Right.
And yeah, that's something we will also seek people's help from. We're currently building the infrastructure to do this, but the idea is we have Jupyter notebooks. We already have a couple of these on our website. So if you look now, there's a little example button that just appeared yesterday. And we're building a little OHBM abstract about this where we show these things. And the idea is, having an executable notebook that is also automatically tested, because we found in the last years, we wrote tutorials and like a couple months later, they're not working anymore because data sets has moved or things have updated. And Neurodesk helps with this already a lot, but we still can't control the outside world, right? We don't control data where data is stored. So that's the cool thing. We will automatically test these notebooks and we produce a really nice website. So you have material of, okay, well, this is how you do a registration with Greedy, and that's how you do an M-matrix evaluation. So this is coming, and we're looking forward to people's help there. So yeah, we will build the infrastructure, and then hopefully people help us to build out the materials. And yeah,
excellent. I'm really excited to hear about that. And also for people who are not familiar with Jupyter notebooks, it's written in Python, and these are interactive notebooks where you can execute Python code cell by cell, see the output, change things, and also it interacts with the web quite well. So as far as downloading data sets from OpenNeural, for example, it works pretty seamlessly, I would say. So for those who are unfamiliar with Python, Jupyter notebooks, just the way the field is trending and what the developers are using these days, it seems like it's going to be a necessity for new graduate students, in my opinion.
Yes, and can I just add, it's not just Python, it's Bash. We can write Bash scripts inside a Jupyter notebook. So you can do a little % Bash, and then you just have a Bash cell. You can do R, which is fantastic. You can do Julia. And I think this is where the name comes from. It's Jupyter, so JuPy-R, and it's actually Julia Python R. That's how it was built initially.
Oh, okay.
So you can actually also do really cool R analyses. Currently, a lot of our examples are Python and Bash, but I would be really keen to see people contributing Julia, R packages. I know our community has a lot of R people, and especially statistics, we could do a lot. And yeah, let's see what we can do there.
Steffen, what are your thoughts about standardization in general? So where I'm going with this, fMRI prep came on the scene about 5 years ago. This is a standardized pre-processing pipeline developed mainly by Russ Poldrak's group out at Stanford. Essentially, the philosophy is let's use the best of each software package that's out there. Maybe this program has the best co-registration, this one has the best normalization, and just put it in a unified pipeline. And now there are talks about a similar approach to statistical testing and inference. So obviously this aids reproducibility immensely. I think it's been a great asset to the field, and I'm very grateful for it. But with standardization overall, do you see any risks in that? As in, people get the convenience of having you just put in your data set, you press go, set it and forget it, as opposed to doing everything from scratch, having basically this babel of different labs where you can't really run a script from another person. You talked a lot about the continuum. I just want to come back to that, from pre-processing to statistical analysis. Where does Neurodesk fit in there?
Yeah, we thought a lot about this as well.
It's a broad question. Sorry,
it's a broad question, exactly. And I will answer it with the thoughts we came up in discussion in our group as well in the last years. So I think what standardization ultimately does is it abstracts away details. So for example, fMRI prep, right? So when we did our PhD, we had to do this manually, right? fMRI prep didn't exist. I did a lot in SPM. I learned about registration. I learned about nonlinear registration. I learned about all these steps and all the things that you could do wrong. And I'm pretty sure that some of the things I've done in my PhD are not correct. Or could have been done better. Let's say it this way, right? So I don't think it's wrong, but it could have probably been done better if I had known. So, and I think that is the big advantage of these standardizations. I think fMRI prep, MRI QC, ASL prep, they really take the wisdom of lots of people, communities, and it's open for debate, right? You can go in fMRI prep and change it. If you have a better idea and you can prove it, go in and do it. So I think it really helps to minimize noise, and it probably gives people just objectively sometimes good answers and better answers than if they would have done it alone. And we are in the same camp. Like QSM-XT is basically fMRI prep for QSM. We start from DICOM and we give you everything, segmentations, the QSM maps, everything. The downside is that then people don't understand anymore what they're doing, right? So because that's the black box approach. You run fMRI prep and you get stuff. Yeah. The challenge now is if you are not doing bread and butter fMRI and you're doing weird things, then these standard approaches might actually give you problems. They might actually give you wrong things. I think has been bugs, or not bugs, but just things that were not documented that well with, for example, how regressors are applied in certain scenarios. Right. So what I recommend to people is, and I think this is in general true also for all the technology we use, abstraction helps us to do new things, because now we suddenly don't have to spend a PhD anymore on registration. We don't have to understand all of these things. So we are now one level higher. This means we can do new things. We can achieve more. But it still means I think we have to understand what we're doing. So what I always tell my PhD students as well is you have to go one level deeper than what you're using. So if you use fMRI prep, you should understand what's ends, what are they doing in registration, why did they use free surfer in there, what are motion regressors, how do they work statistically. You just need to understand that if you want to use it robustly. And if you don't understand this, I think you're risking that you're doing something wrong. But then it comes with great power, right? Once you understand it, it's a lot quicker to understand it than doing everything yourself and doing everything from scratch. So maybe it's good to just exercise, do an analysis from fMRI prep yourself, just code it together yourself, tinker with it a little bit just to understand that you're getting something yourself. But then, use the standardized approach. And I think that that's really good and very powerful. And then, we just need to be transparent about it. And I think this is where these pipelines help as well, because if you say you used fMRI prep 2304, everyone knows what you did and can reproduce it. If you write in your paper, I used ENS 341 and I did a registration, it's probably difficult to reproduce that. So I think that becomes, again, we need to be transparent about what we're doing. Neurodesk helps with that, right? Because you have to make your assumptions explicit. If you code up things with ENS, so it gives you that option to be on that level of detail. But you can use fMRI prep if you want to. and it just gives you that option, and it makes it explicit what you used and just forces you to document it properly. That's, I think, where we fit in. What's our philosophy there? So we do offer these tools, and I think there's great value in them, but we also allow people to go deeper. And I think this is my philosophy with this.
We're in complete agreement about that. Obviously there's a limit to the level of granularity that people can learn and apply, because we're dealing with so many different things. We're dealing with MRI physics to advanced statistics to co-registration. A bunch of different things come into this. And that also gets into another relatively broad area, but I really want to get your opinion on this. So, Steffen, you are, from my perspective, a very accomplished programmer. You and your team have done some very amazing things, which is making my life a lot easier and the lives of other people much easier as well. Something that I'm noticing, let's say the past 10, 15 years, I finished my PhD roughly 10 years ago. There's been a large increase, I would say. Again, I don't have hard data to back this up, but a large influx of more high-level computer scientists and programmers. So it seems like right from the go, they're very fluent with things like Python, with Jupyter notebooks, with the ins and outs of data science, especially. Now, we also have a lot of people in the field of neuroimaging, where I come from, who they know enough to get around a Unix shell. They may be able to run a Jupyter notebook, but they're not as, let's say, technically proficient, especially in the computer science, data science areas, but they may have great intuition about psychological theories, and they just want to implement some kind of pipeline and analysis and so on. So what would you say to those people who are not necessarily that inclined to learn the ins and outs, the really nitty-gritty details of Python and so on, but who have pretty good ideas about experimental design, what they want to analyze? What would you say to them about when they're first approaching Neurodesk? What do they need to know? If this is you talking to your PhD students, for example, what are the basics they need to know going forward?
Yeah, that's a good question. Yes. So I think ultimately it's hard to avoid learning these things. So if you want to analyze big data, you just need to be able to program ultimately. But one thing that we do in our group, and I think I see this very successfully in other groups as well, is I think diversity in a group. I think you need people who have a medical background, a psychology background, statistics, programming background. And I think if you get people with diverse backgrounds into a group, you can do amazing things. And I think that's what I would recommend to people. If you have great ideas in psychological theories and how to test them, and you don't know how to program, find someone who can and get them on board. Because I think learning everything is really hard, but learning a little bit from someone else to be enough to talk to them, that's probably what I would say is a first goal. Get a shared understanding of what you're trying to do. And I think, we shouldn't be in ivory towers and just do one thing. And I'm just good at programming, right? I think if you work in the space, you need to understand statistics and you need to understand how to do an experiment, because you can be a very good programmer if you have crappy data. There's no point in doing it. And same thing, if you have great data, you don't know how to analyze it, it's also a waste of time. So I think having diverse teams with these different experiences where people can teach each other, I think education materials are great, and that's where you're contributing a lot, where we just need to get these basic skills out to people. At the same time, make it easier, right? So that's what Neurodesk does. We make it easy. You don't, I think, to analyze fMRI data, you shouldn't have to know how to compile FSL. It doesn't make sense. So that's what we're doing. We're taking this away from you. You don't have to deal with that. You don't have to understand all these different versions of Python, but you do have to understand what a regressor is or an EV and why this works in certain ways in the software that you're using. So I think that's what you need to learn. We can't take this away from you, and we can't do analyses automatically for you. You still need to understand these things. And we can make it easier, but I think, this fundamental understanding, exchange with our peoples, that's probably the key to make progress. And that's why I see a lot of successful teams in the world do exactly that.
Yeah, I think Neurodesk is an important step in that direction, definitely. Not just reproducibility, but giving people a shallow ramp just to get started with it. Because you already pointed this out and you explained it pretty well, but when somebody sends you their scripts to analyze something, I mean, everybody's been there. Everybody has had a script that just did not work and they felt very discouraged. They did not know what to do. And yeah, I mean, obviously can't make everything perfect, but more perfect is a reasonable goal, I would think.
Yeah, exactly. Yeah, I agree.
Well, Steffen, I think we've covered a lot of what we were planning to discuss, just some of the history, what you're working on now with Neurodesk, some of the potential, what you're planning on doing in the future. I realize we only have a few minutes left. Unfortunately, I got to go in a little bit. It's evening here. It's morning there. I know, big time difference. But any last words about your projects, your work, about the field in general?
Yeah, I think last words is we need the community. So everyone who's keen to help us with Neurodesk is more than welcome. So reach out to us. Let us know where things could be improved. And I think what I always ask people is don't just say, oh, I want the software, but actually try to edit yourself or give us some help as well, because we are a small team. Like there are currently a handful of people really actively working on Neurodesk. So there's limited things we can do. We have to work on the underlying infrastructure. So especially the peripheral things like documentation. And if you see a typo on the website, just click edit. We made everything community editable. And this is always something we build into everything. We want this to be a community project. It shouldn't be a project that's run out of one lab. Because also, I think John Baptiste Pauline always says this, the bus factor, right? If I get run over a bus, what happens with the project? And I'm confident to say today
I've never heard
that
that before.
yeah, exactly. And I think it's
Factor.
true, right? I think
That is true,
projects
yeah.
like this shouldn't be run out of one lab. And I think BIDS is a fantastic example how it started in one lab, but it's now worldwide adopted and people understand enough from BIDS to keep the project alive because it's just very useful and it's super good. So I think that's also where I encourage the community to get involved. It is, we didn't build it just for us. We did it in the beginning because we had our problems. But in the end, we said, let's build this out for everyone and get involved, help, make it better. And with this, I hope people are excited to use it and to learn and get cool stuff done in the end. Because I think that's what I ultimately want to do, right? We want to do cool science and have sustainable science as well. So that's efficient, that's reproducible, and that's good science in the end. And that's open. I think that's something I love. And maybe we can end on that one.
Well, best of luck to you and your team. I'm really looking forward to working with you as time goes on. I'm hoping to be at Brisbane to possibly assist with that workshop, and we'll have more details the closer we get to the date.
Yes. Thank you so much for the invitation.
Right. No problem. Steffen, thank you so much for your time. Good luck, and I hope to talk to you soon.
Thank you.